if I have the sine of x equals 2/3 in quadrant 1, what is going to be the cosine of x, the cosecant of x, the secant of x, the tangent of x, and the cotangent of x equal to? Well, what's the easiest one to figure out here on this whole list? Given the sine of x, what's the easiest one? Not cosine. Cosecant. Cosecant is the what of sine? It's the reciprocal. So cosecant is 3/2. Done. Now, let's do the cosine. How do sine and cosine relate? Well, sine squared of x plus cosine squared of x equals 1. So 2/3 squared plus cosine squared equals 1. What's 2/3 squared? Well, that's 4/9. What do I do to each side to solve the equation? Subtract 4/9. Cosine squared of x equals 1 minus 4/9, which is 5/9. Then take the square root of each side. So it's the square root of 5 over, what's the square root of 9? So the cosine of x is square root of 5 over 3. How do we find the secant of x? Well, the secant of x is equal to 1 over cosine of x, right? So it's 1 over the square root of 5 over 3. So it's just a reciprocal of the cosine of x, right? So it's 3 over square root of 5. Can we leave square root of 5 on the bottom? No. So we have to multiply top and bottom by square root of 5. So it's 3 square root of 5 over 5. Tangent. What's tangent equal to? Well, we could take secant squared equals tangent squared plus 1. But that's too complicated. Tangent is also equal to sine of x over cosine of x. So it's 2/3 over square root of 5 over 3. It's a complex fraction. How can I get rid of a complex fraction? Multiply by the denominator of the denominator. What's the denominator of the denominator? 3. 3's cancel, 3's cancel. So it's 2 over square root of 5. Can I leave it as 2 over square root of 5? No. So we multiply top and bottom by square root of 5. So it's 2 square root of 5 over 5. Cotangent of x is what over what? Cosine of x over sine of x. So it's square root of 5 over 3 over 2/3. Multiply top and bottom by 3. Square root of 5 over 2. We can leave it like that. Ta-da! I got the other 5 trig terms using trig identities. Okay, let's do one more. Nope.
I don't learn anything when you.
We'll watch the video. Slow down the video at home. All right, here we go. Let's say the cotangent of x is equal to negative 2/3 in quadrant number 2. If we're in quadrant 2, we got to figure out what's positive, what's negative. So what don't we have if we have cotangent? Well, we don't have the sine of x. We don't have the cosine of x. We don't have the cosecant of x. We don't have the secant of x. And we don't have the tangent of x. Out of all these, what's the easiest to find? The tangent of x, because it's just the reciprocal of the cotangent. So what would the tangent of x be? -3/2. Bada bing, bada boom. All right. Cotangents in a Pythagorean identity with what other thing? Cotangent shares a Pythagorean identity with cosecant. So I know that cosecant squared of x equals cotangent squared of x plus 1. So cosecant squared of x equals -2/3 squared plus 1. What's -2/3 squared? So we get 4/9 plus 1. 1 is the same as how many ninths? 9/9. So it's really 4/9 plus 9/9, which is 13/9. But that's cosecant squared. I want cosecant. So I take the square root of each side. Cosecant of x equals the square root of 13 over 3. Now, we are in the second quadrant, which is right up here. Okay? So, what is cosine in that quadrant? Positive or negative? Negative, because we're going left. What is sine in that quadrant? Positive, because we're going up. What's tangent in that quadrant? Negative, because we're going sine over cosine. Positive over negative is a negative. Okay? So since sine is positive, its reciprocal is positive too. So cosecant is positive. All right. So if cosecant is the square root of 13 over 9, whoop, if cosecant is the square root of 13 over 3, then what's the sine of x going to be equal to? 1 over that, or just the reciprocal, 3 over the square root of 13, right? Can we leave the square root of 13 on the bottom? No. So you multiply top and bottom by square root of 13. So it's 3 square root of 13 over 13. That's the sine of x. Cosine of x. Golly. Maybe I don't want to try to find the cosine of x because that's really complicated if I use the sine of x. How about I find the secant of x? How is the secant of x tied into anything? What's the Pythagorean identity with secant of x? Tangent squared of x plus 1, right? So if I have the tangent of x, I can say the secant squared of x equals the tangent squared of x plus 1. And then it's -3/2 squared plus 1. What's -3/2 squared? -3 times -3 is 9. 2 times 2 is 4, plus 1 is 4 over 4. So secant squared of x equals 13/4. If I take the square root of each side, secant of x equals the square root of 13 over 2. Will it be positive or negative? We're in quadrant 2. And secant is a reciprocal of cosine. So cosine's negative, so secant's negative. So how do we find cosine now? Flip over this fraction, right? Cosine of x is 2 over square root of 13. Multiply top and bottom by square root of 13 over square root of 13. So it's 2 square root of 13 over 13. And it's going to be negative. Now, look at these two. Sine over cosine is what? Sine over cosine is tangent. Is 3 and all this gobbledygook over -2 over this gobbledygook equal to -3 over 2? See how that works? Okay. Start making connections. All right. So your assignment over all this fun stuff is on page 165 again. We are doing problems 15. No, we're doing 21 through 24 all. 4 more problems. Okay, so those of you who missed that Friday who didn't have today's assignment done when you came in here, get that done for next time and then show it to me so I take off the missing off your grade. I'll come around and look at everything from 15 through 24 at the start of class next time. 15 through 24. You already got 15 through whatever done. Okay. Yep.